We want actually to see if people have a cancer or not. I want really to show to the students and the professor here that metal complexes, so it means compounds which contain a metal, are extremely important in medicine. And what we have successfully found out is a new compound which can be imaged with zirconium-89. And we really hope that this compound will enter actually clinical trials this year.
Tengo el placer de presentaros a Gilles Gasser, un científico suizo que está visitando la Universidad de Burgos con el objetivo de impartir una conferencia sobre el uso de drogas con metales en el ámbito de la medicina. Su trayectoria como investigador es impresionante y su currículum muy envidiable. De hecho, es coautor de más de 100 publicaciones en revistas de reconocido prestigio internacional que han recibido más de 4.000 citas. Además, es miembro de 6 instituciones académicas y científicas y ha sido reconocido con más de 20 premios también de tipo científico. Espero que la entrevista que le hemos realizado en la Universidad de Burgos os ayude a comprender mejor los conceptos que va a exponer en su conferencia.
First of all, it's a great pleasure to be here in Burgos, and I thank my host, Gustavo. It is really a great opportunity to be here because I want really to show to the students and the professor here that metal complexes, so it means compounds which contain a metal, are extremely important in medicine. Quite often people believe that metal complexes are toxic and are useless in the field of medicinal chemistry. And this is wrong, and it is actually totally unfair to say that metal complexes are toxic because they are used every day, everywhere in the world to treat patients. 50% of people who have cancer are treated with a metal compound. And we can continue and say more examples. And I want really today to show this here in Burgos. The compound which is really heavily used against cancer is called cisplatin. So it is a compound based on a platinum-2 compound. The idea here is to actually inject intravenously. So the patient going through chemotherapy are being injected the metal complex. And afterwards, this metal complex will undergo several chemical transformations to reach the nucleus of cancer cells, where they will bind to DNA. And once the platinum is binding DNA, the DNA cannot anymore proliferate. They cannot anymore create new cells, meaning that the cells will die. And it is how you are actually treating patients with cancer. Because the cancer cells are dying, the patient will survive. So the point of our group in Paris is actually to work with metal complexes in 4 different areas of medicinal chemistry. The area which is actually the most promising today, and it is what I will present first during my talk, is actually radio imaging. We want actually to see if people have a cancer or not. This is the first diagnosis that you want. Before treating someone, you need to know if she has a cancer. And what we have successfully found out is a new compound which can be imaged with zirconium-89. We inject, for example, mice, and we clearly see that the compound is going uniquely to the tumor. And we can really target certain type of tumor like this. And we really hope that this compound will enter actually clinical trials this year. The other compound that we are currently investigating is in the field of schistosomiasis. Schistosomiasis is a very important parasitical disease in the world. It is the second most prevalent parasitic disease in the world after malaria. What is very surprising is that a lot of people don't know about this parasitic disease, which affects millions of people in the world. The problem is affecting many people in poor countries. So what we are currently trying to do is to investigate a totally different type of complexes, organometallic complexes. It means that the compound contains at least one metal carbon bond. And we have seen that one of our compounds is extremely promising because it can actually work on species of the parasite which are for the moment not tackled by the organic counterpart. And this is extremely promising, and we hope to start this year already trials on hamster. So photodynamic therapy is an approved medical technique. I like to say it is approved, it is already used in several countries. The point is to inject a compound to a patient, wait until this compound is reaching the tumor. When it is reaching the tumor, the doctor will irradiate with a laser a surface area. And only on this surface area, the compound will undergo a transformation, becoming toxic. This is very interesting because it is extremely localized. The compound which is here, if it is not irradiated by the doctor, nothing will happen. And this allows to have a very temporal and spatial control of the cancer treatment. And the compound that you inject is called a photosensitizer. And what we are doing in Paris is to create novel compound which will allow selectively to the tumor, to have a double selectivity. The problem for the moment, what is on the market, the compound which is injected is going everywhere. Since the doctor is only irradiated here, you will have only this surface treated. However, when the patient will afterwards leave the hospital, he will go, for example, today in t-shirt because Burgos is very sunny, he will get sunburns because the compound which is still here will actually be activated by light and you will have a lot of side effect. So what you want actually is to have a compound which is going just here, to have this double selectivity, and it is what we are currently trying to do in Paris. The point here is you have two ideas. You can have either a compound which is metabolized much faster, so it means it's going everywhere, but afterwards it is excreted extremely rapidly, so it means that the patient has to stay at the hospital maybe only one day before going to the sunny Burgos, or to have a compound which has a biomolecule which is only selective to cancer cells, like an antibody. That's how we are currently trying to manage this. Actually, I will say that there is starting to have a bit something changing in industry, because it is true that 10 years ago industry were extremely worried about metal complexes, but with my experience I have seen that they are more and more keen in hearing what we have to say, because they have seen extremely positive results. Ruthenium compound, for example, have already entered into clinical trial. A photosensitizer, the type of compound that we are currently investigating, has been found by a colleague in Canada to be extremely active against bladder cancer. And it is in phase 1B already in Canada to treat bladder cancer. And you see so many now positive outcomes. So it means that industry are saying, oh, let's give a chance to such metal complexes. And I'm very hoping in the future, maybe in 10 or 20 years, to have 2 or 3 more compounds either in clinical trial or approved. I like also to say this famous example against malaria, ferroquine, a compound containing an organometallic compound, ferrocin. It is actually in phase 2B clinical trial. It has been bought by the pharmaceutical giant Sanofi, which is, I think, the second biggest company in the world. So it means that such companies are ready to study metal complexes, provided, and this is what we have to do, us in academia, we have to give them very good results. We don't have to hesitate to go for in vivo experiments and to come with results which are comparable or even better than with organic compounds.